unusual data.
Oh, hello everybody, and welcome to this talk about botnets and things that you can get from them. My name is Alex Holden. I'm Chief Information Security Officer for Hold Security. We are a threat intelligence and dark web monitoring company. And the reason I'm talking about botnets today is that for over a decade, it's been my passion figuring out the biggest and worst cybercrime groups out there and what they're doing. There are lots of different ways of cyber criminals attacking the systems, the ways to abuse the data, breaching databases, stealing information. But the most common way and most potent way today and over the past decade been virus infections and data stolen over the virus infected machines. So number of years ago, we started exploring these things. And from my work with Brian Krebs on Jabber Zeus gang and figuring out how Zeus botnet worked, Game Over Zeus, and many others, we got very interested in mining data from those botnets. But how do you mine data from something that you can't see and it's hidden by default? Well, we tried to approach this question with social engineering because breaking into botnet panels possible but very difficult and you get kicked out. But when you get invited through social engineering of cyber criminals, you definitely get a first a raw view of all the activities. And this is what we're going to be talking today, our insight into the botnets, what we are seeing and how we see things progressing. So the botnet is much more than a virus infected system. We'll talk about the types of botnets out there and what information it's gathering. The typical data types that we see being traded through the botnets and the information that is stolen in addition to just the typical data types, and also understanding botnets, how we can use their information for good to defend things, and also what to do when you investigate botnets. How do you defend your identity and hide yourself from this type of research? So first, we're going to be talking a little bit about typical botnet to give you a little bit of background so you know what we are talking about. And I'll explain more particulars in the detail, but just to give you an idea, that first we're going to be talking about the virus distribution networks and how the viruses get on the systems through driving traffic and getting infected emails or malicious websites to load malicious payload on your machine, something through what they call loader. Use the dropper. That's something that that gets ingrained in your system and it distributes itself throughout your system, hiding itself from the security software like antivirus and anti-malware components, agents that the botnet is building, and communications with CNC or command and control centers, or C2s for short, and then also this data distribution network behind the botnets. So a lot of things to cover, a lot of real life examples and stories. So first, I want to give you a brief introduction to command and control panels. We're going to be talking about them in detail throughout today's presentation, but the biggest thing is to give you an idea that not all command and control panels are created equal. Not all of them are useful. Not all of them are interesting. But first of all, in C2's size matters. Amount of data that being stolen is very important from the defense side and also from the size of cyber criminal organization. There are a lot of C2s that do service type of model where somebody can rent a part of it for their own purposes, and those are extremely small. And then we'll today talk about the bigger ones like Amatet, Gozi, Trigbot, and many others, which are extremely large, one of the largest botnets out there today. Variety of them, what they do and how they function, and also understanding that botnet command and control centers don't always offer data. Some of them done for distributed denial of service attacks. some of them done for different purposes, even as simple as proxy networks to hide malicious traffic from their original source. So let's get started. Let's talk about the botnets and how initially the infection makes it to our machines. First, we will discuss the traffic generation, the way that the bad guys actually distribute their payloads, and a lot of it obviously happens through email. People click on things all the time, but that's not the only way that the bad guys are distributing things. They're also building these type of panels that I'm showing right now, and this is one of the Amatet distribution panels that is driving traffic, web traffic, through different advertisements, through again malicious clicks through email, or even things that you go and search through Google Ads or anything like that that gets built in the search engines um, toward the top through various manipulations. So this is a very simple panel that driving traffic to a particular malicious website. It keeps track not only of who comes in, but what they do, what kind of browsers they have, what's their locale, and if they're successful in the payload distribution or not. Keep in mind that in this stage, when the virus just hits the intended target, it's still not going to be 100% successful because the antivirus is good for something. Not much, but it does prevent some infections from happening. And in many cases, we see about 30 to 40% success after the infected machine or machine comes to the site and tries to get infected. And then the bad guys also do management of their campaigns. They manage their campaigns, malware campaigns, through very standard tools in very similar way to figuring out the success of a normal advert campaign. They are trying to figure out how successful it was, and they actually pay out their campaign managers for success. It's definitely pennies on the dollar or much less, but definitely we see the success rates for the bad guys exceeding some expectations, and they are showing how much infection they drew through a certain campaign. Once the machine gets infected, it goes inside of this C2. And this is where we're going to spend a lot of time today discussing and showing ins and outs of those components. When the virus is on the machine, it's gathering a lot of information, and the bad guys want to know as much information about the machine as possible. So they are engaged in really cool control panels that show a lot of interesting data. They show demographics, they show geographical distribution, and so on and so forth. So this is an example from the TrickBot botnet, which shows for a particular campaign how much infection, how much data point infected they were able to make. And we can create these graphs ourselves. So for our analytics of logs and the information that we got from botnets like Amatet, we actually build these type of graphs for ourselves using their victim data to figure out where the biggest infection components are happening. So in early 2020, we actually saw a change of the game, not only because of COVID onset, but also because of the change in tactics in some of the major botnet operators. So for example, Amatet, you can see by this hit graph, is not targeting United States as much as it's targeting Europe, Middle East, and Far East, like South Korea. So the focus also very important to monitor, and the intention of cyber criminals who operate in those botnets is also showing to shift from the standard attack United States make a lot of money to attack the world make even more money. And then we see the progress in different botnets like Anubis, which source code was leaked online well over a year ago. The adaptation and continuous development of this mobile botnet software is actually taking new leaps in its progression. So we actually noticing that they build more components around biometric monitoring. So Anubis is Android-based botnet, and it's using Android's feature to monitor eye movements of the user if to figure out if the user is looking at the screen or not. And if this feature is enabled, Anubis actually reports it to its panel. It's also grabbing information from the pedometer, counting number of steps that the person is making. No, it does not care about your health. You can be as active or as inactive as you want to be, but the reason why it's monitoring the eye movement and the steps is to figure out if the victim is using the phone actively, if the victim is looking at the screen. Anubis, some of its manipulations may be visible to a person who is actively looking at the screen. So the bad guys figure out if they check for eye movement, if somebody actively looking at the screen, or they assume that if a person is walking and doing something on the phone, they're not likely paying great attention to their screen. So they're getting that information proactively and creating appropriate reactions. They also build certain protections on the mobile side against antivirus. So it has an exclusion list of a lot of antivirus software for Android that once Anubis botnet is installed on your device, it's actually going to be uninstalling the security software that you may be trying to load after you've been infected. It will uninstall, but it will report success. It will even install an icon in the list of your applications that to show you that you installed something, but when you click on it, it does nothing. So intelligence built into Anubis and many other botnets is extremely important. Another TrickBot component is to monitor amount of bots online throughout the day. It monitors it specifically to figure out what amount of firepower does it have. If they try to do distributed denial of service attack or anything else, they need to know what amount of traffic they can anticipate and what they can sell to others. They also like to provide big picture. A lot of analytics built into these C2 panels to show the bad guys what they have and what success rates are. Not only the currently systems online, the geographic distribution, but also success of every specific spam campaign, phishing campaign, or malware campaign that they have, because they give different regions, different viruses, different approaches. So a lot of components on the big picture is also needed. The big part of the botnet, unfortunately, is our injects. These are specific injects to emulate or intercept data for major applications. Usually it's banking, social media, large shopping sites, or anything that can be used to steal financial information or other major data. The bad guys seek access to email systems, but to control some of these components. For example, Gauzy is intelligent enough to figure out if you are constantly logged in to an application, for example, Amazon, that does not really log you out, to capture your credentials for Amazon. It can, because it's built in as a just a communication token. So from that perspective, GoToBotnet actually logs you out from different applications, from banks, from Amazon, from PayPal, and others, to see how you log back in. Once you are logging into the application, it's using these injects to figure out your typical behavior. You know how you log into a financial application over the internet for the first time, it's going to ask you a whole bunch of interesting information. Not only your username and password, but also will ask you for additional information, secret questions, your mother's maiden name, maybe your social security number, the number on your bank card, or anything like that. So these injects actually build between the website and the victim in an emulator of the virus. and they are instructed to steal additional information. So the bad guys can emulate that behavior and try to log in as you on every single level. And later on, we'll actually go through an example of how this data can be stolen, how can it be used or abused on different levels. Actually, going through an example of stolen data abuse. And then the bad guys are constantly adding new features, the new features for themselves to make their lives easier, and some of them for security researchers like ourselves to get as much data from the panel as possible. So this is an example again from Anibus or variant where they build a stealer and it's misspelled for some reason that allows just to harvest credentials within this particular botnet to download it all together in one command over a period of time. Botnets also go into more intelligent mode. Vidar botnet is well known to actually harvest information and classify what kind of data it has within its repositories. Does this exploited machine have PayPal account? Does it have a Netflix account, or they have any connections to banks or anything else? So then, when looking at this, when somebody looks at it, they see what information is available, and they can do intelligent selection components to figure out what can be gathered from this particular machine. Based on Vidar botnet, a big website that offers botnets logs for sale, Genesis.market, is actually using the base of Vidar to sell one botnet record at a time. So if a malicious person logs into this particular market, they have no access to data by default. But for just a couple bucks, they can buy particular bots with particular information sets. And this pay-to-play model is becoming more popular with these type of botnets. Genesis Market has about 311,000 victims within its database right now. So let's talk about the standard valuable botnet data. What's interesting to the bad guys and what is not particularly useful from their perspective. Now, when information gets stolen from a machine, the bad guys don't try to differentiate what's can be valuable right now or later. They're kleptomaniacs. They try to steal as much data as possible, but certain data is increasingly more valuable than others, and some of it is basic logins information. As I mentioned, not only username and password, but significantly more data than this is stolen from financial institutions, shopping sites, social media, reward programs, hotels and airlines, for example, because those are monitored significantly less than others from a perspective of fraud or abuse. Also, law enforcement is not very apt to protect the reward programs because a lot of reward points, miles, or anything like that have $0 value. And no matter how many points somebody steals, it's still going to be a $0 value unless they try to cash out for physical goods that have value. Now, one of the biggest directions in 2020, one of the most valuable points is corporate data in form of Citrix and RDP access. Some of those accounts go upwards to $25,000 per single account in hopes to install ransomware on corporate networks and gaining significantly more money through ransom. Gambling sites also very often stolen because quite a few cyber criminals have gambling addiction. And we've seen cases where cyber criminals get access to somebody's gambling account, go in and gamble with somebody's money. They don't care if they win or lose. They just enjoy themselves at somebody else's dime. If they win, obviously they can try to cash out the money from the winning account. So financial data, besides the direct information, access to the banks, maybe in forms of credit cards or bank information, maybe Bitcoin wallets and other components. And beside that, this onslaught of data that the bad guys try to steal for future abuse, including PII information about other components, and they steal additional information, including screenshots, files for the future use and abuse. As I mentioned, I want to show you an idea about the data that is being stolen. When a botnet virus gets a hold on your system, it's not only stealing usernames and passwords. That's thing from the past. Yes, it steals that information, but there's so much more to it. So here's an example of a UK banking account that was stolen and trafficked on the dark web by the cyber criminals. It's simply much more information than a standard component. Let's just take a look point by point. So name first, we got rid of some personal identifiable information to keep the victim's identity safe or from further exploitation, rather. So this lady Allison, who was born in 19 something in March, lives in UK. There is full information available, and phone number, email address, driver's license number, national insurance number, which seems to be equivalent of our social security number in UK, mother's maiden name. The bad guys also found a picture of a person's passport on her computer, and they uploaded to Imgur, so the abuse and the identity verification can be easier. So that's page one. Page two has financial information. We see her banking information from the BIN number, bank identification number, which is Lloyd's in UK, what kind of card this is, information about the bank, the website, just in case, and the phone number if need to be called. For the serious abuse, the bad guys are not afraid to pick up a phone and dial and impersonate this person, try to gain full access to her account. And they have call centers, so even if it's a male cyber criminal, they can go through another cyber criminal call center to instruct female callers to impersonate Miss Allenson, and given all her personal information. Now we got the name of a credit card. We got the card number itself, expiration date, and additional information. Page three, we got finally CVV, date of birth, and finally on page three, we only see a password. So it's not just one set of data, it's a lot of data that all combine into a single profile. The login information for this person, her last known IP, user agent, and additional components, cookies that she might have used recently. Lastly, there is additional settings for FraudFox, which is an emulator for Firefox portable that is able to take identity of any browser or device given the full profile. So it's going to emulate Allison's browser in all the details. It has all the data that's listed over here, plus this full profile, which is a fingerprint of her browser as it would appear to any system that tries to inquire and identify her machine. So if the bad guy uses a right proxy, they would have all the information about Allison and also all technical information that they need to fool Lloyd's defenses to get in. So this is seriously more information. Yes, there are better defenses against this. Yes, there are additional footholds that somebody can use to identify all this fraud. But you have to appreciate how much data is being stolen from an average machine in order to abuse a single credit card. And the abuse is very likely if the credit card activity would not raise any other suspicion. So let's talk about other uses of this botnet data for good, for information that we can use for on the defense side. First of all, we need to recognize that botnet data is mostly correct. So it's an end user that is actually providing this information. It's not a guessing game. It's not brute forcing. It's not the reuse of data. It's specific data from a particular source. Yes, users make typos. Yes, they forget their passwords or try to log into things that they don't should not be logging in. That information would be incorrect. But the vast of majority of other data would be 100% valid and correct at the time when it's being entered. It's also extremely well documented. So the botnet records sit within database, and it shows every single step of a system, how the data is being stolen from there. So it's useful to get for forensics, for investigations, and to understand the full impact of a single virus infection. It's also, in many cases, extremely well illustrated. The bad guys take pictures, and we'll go through that in just a bit. But the new trend is, as a virus gets on the system, to take a screenshot and also take an image from a web camera if it's attached to the machine. So in many cases, we are finding that these type of activities capture images that extremely unusual, especially the web cameras that capture images of things in front of them. In many cases, we are finding out these are people behind some computers are kids, and spying on kids through web cameras is a different type of wrong. We also seeing within botnet data the research notes from the bad guys. They actually do a great job documenting things and leaving their remarks. So in many cases, in case of breaches or especially ransomware, we can reassemble based on these notes what had occurred, and in some cases prevent breaches from happening because we would see the real-time note updating within certain botnets. We did one interesting experiment in collecting stolen credentials. In many cases, we can't tell where the data is coming from. If it's a uniform dump from a single source, and usually there are ways to figure out that if the data that we're looking for in credential dump coming from a single source or not, based on how many user IDs there are and if there are any redundant ones. We still don't have much information about where it came from. If the bad guys don't mark something stolen from here or stolen from there, it's hard to tell. But credentials can be compared to the other information. And if we map the credentials to the botnet data, we are starting to see a lot of different components. We got over 10 billion botnet records. We got over 12 billion unique and unencrypted credential records. So we can compare these two for our purposes to figure out some dumps of data, especially credentials, and figuring out where they come from. We can match based on usernames, and we can also match them on passwords. We can figure out the dates because botnets, as I mentioned, extremely well illustrated and documented. So when something was stolen and how. So we can figure out based on the data that is present in the botnet logs and the data that's present in the credentials, to figure out not only where the data is coming from by looking at significant matches of credentials from botnets to the credential dump and seeing that it's matching to a specific victim, but we can also tell when this potential when this dump had happened based on the data that's present in the credential dump and based on data that's not present in the credential dump. So if credential dump happened in 2018 and we got 2019 botnet data, that some of the registrations in 2019 simply didn't happen yet when the breach occurred in 2018. So we can actually predict this and say the breach had happened this year or that year because we got additional information about accounts that existed or in the system or did not exist yet. And also we can see that people change their passwords throughout their presence. So we can see that if somebody changed their password after the breach or before the breach, it's also going to be reflected in the credential dump compared to the botnet data. We also are able to do additional advanced tracking and figuring out how infection took place. What kind of device was infected? Is it a desktop or mobile device? What kind of what happened to this device? Did it change its IP addresses? Did it move from the personal network where it was less protected and most likely got the virus there, down to its corporate location? Also tracking movements. Similar to Anubis botnet, we can see if somebody is moving around or not. And for Anubis, they actually implemented the integration with Yandex Maps, so they can understand the physical movements of the phone. And when they emulate that phone, they can be hiding to specific IP location within physical locale where they are located right now versus where they actually registered the phone, because people used to travel, at least until now. And also, we see corporate assets exploitation. Botnets like Amatet, when it establishes its base on the machine, start exploring local network, local Active Directory, to figure out how many devices are within specific AD, if it's a workstation, if it's standalone, what AD force looks like, and so on and so forth. So these things that actually being harvested by botnets, extremely useful for us to understand and to track later on. I want to take you on an interesting journey and show you, as I mentioned, the screenshots that are being taken by a virus as soon as it establishes its foothold on the machine. So a virus infects an end device somehow. And what it does, it needs to hide itself first from the plain view. It disables antivirus to a certain degree. It cripples other detections on the system. And then it starts establishing its foothold. It realizes that at some point somebody will try to detect it. And C2s actually check for virus being detectable with number of different antivirus solutions, and seeing if these antivirus solutions detect this executable as a virus. If it's detected, it first of all, it checks every single minute. So every minute, the virus on your machine checks if it's still a virus, an unknown virus. As soon as it becomes a known virus, within a minute, it issues a command where it downloads a newly obfuscated replacement for itself that is not detectable, and hands over all the control to this new obfuscated executable before deleting itself from the system. So you may have a fully functional antivirus on your machine that does signature-based detection, and the virus always going to be faster because it takes up to 4 minutes for it to replace itself with a new virus versus your machine checking for new signatures a couple times a day, and in many cases not very effectively. So what happens when a virus gets established on your system? It's when it's done looking around, it takes a screenshot to figure out where it is, and for some logging and for some prosperity. So I kind of want to give you a picture of what the virus sees happening on the desktop as soon as it gets infected. I'm going to start with category 2, because category 1 you can guess, and my lawyers told me that I could not show porn on in my presentations. So we'll start with category 2, where somebody sees something going on their machine. They're not 100% sure what they just installed, so they turn to the antivirus, and antivirus said, hey, don't worry, everything is okay. It says in different languages, in different formats, from different perspectives, and like in Malwarebyte, it even would love to get your feedback. It will want you to rate your virus installation experience and Malwarebyte's inability to detect it on scale 1 to 10. Then the category 3 is to seek help. people in many cases realize they did something wrong, and they start going through different scanning different components, and virus laughs in whatever way it can laugh by just taking a screenshot of somebody trying to seek help to try to uninstall the virus in different ways. And another way people try to cope with installing viruses is uninstalling random software, because they assume that all viruses come with an install procedure, because that's how viruses are supposed to work, right? That's what Microsoft told us. We see very often these kind of uninstall screens where somebody thinks, well, I install something bad, I can just uninstall it. Not every virus comes with uninstall instructions and easy executables within Microsoft environment. Actually, none of them do. So from that perspective, people are being less informed about what they just did, and obviously even less informed in doing other things. The next component or next category of desperation is to install more viruses, because as soon as you realize that you install a virus, you go out on the internet and try to get antivirus. And instead of getting something commercial grade or something legitimate, you go and download some random software that claims to uninstall anything that you just install and make your computer more secure. So this run underscore 0A6AD setup is definitely a legitimate antivirus and installer that would help you with all your security needs, right? So that's another mistake people are making. From the perspective of cyber criminals, we see this new category being much more common. When somebody installs, when virus installs itself on the system, it realizes it's not the first virus that is present in the system. In fact, category 5, where we have people installing random software thinking it's a virus, we see sometimes that this is the virus that we are monitoring is that virus that is being installed as a secondary precautionary component. And in many cases, when you install a virus on your computer, you start panicking, and additional software gets installed. So, for example, DDoS software or different types of ransomware and different attack controllers from all around the world. So from that perspective, just try to understand that victims often don't know what they're doing, and they creating even worse situation by installing more viruses on their machine, panicking instead of seeking professional help. We also did a very interesting piece of research. We tried to figure out who is patient zero on the botnet. Why? Well, usually when the botnet just starts working and they infect their first machine, we get an idea of what cyber criminals are thinking in their infection methods. They are targeting specific networks, is targeting a specific country, and then expand themselves, or like in this case with Romanian cyber criminals, they install their malicious payload on one of their machines just to test how it works. They definitely can uninstall their own virus. They know actually how it works. So their virus may come with uninstall, but what we see in the botnet controller is that first signal and data about their machine. We actually got to one botnet where the bad guys just didn't think about turning off the virus on their machine. It's just gathering information. It's armored system, so it's gathering information for us. From there, we were able to gather all the information about their machine that the botnet collected, including evidence of them running this botnet, evidence of them doing bad things, and exporting victims' data as well on top of it. So patient zero information, sometimes curious, sometimes very important in our investigations. Uh, Now, I want to give you more interesting information about sandboxing. Some of us actually work on sandboxing malware analysis. In many cases, we install a piece of malware within our system, trying to figure out how it works. And in most cases, we need to make sure that it's communicating back to its control center, command control center, so you can see full functionality of the malware. So here's a good example from our friends at FireEye, who did not use all possible operation security options in order to install something on their sandboxes. We found this not because we actually went out looking, but because of various died comments from cyber criminals. Um, I can't even show them on the screen because it's obscene, even though it's in Russian. But don't name your sandboxes like this. It's victim PC. It's not the best name for the sandbox. Also, don't install it inside of your network. It's nice that you may have a lot of IP space. It's nice it's going to be completely segregated, or it can be part of your AD. Don't go and create different issues for yourself. So, a couple advices about sandboxing. Um, Make sure that you're building your sandbox. It's not born yesterday. If your machine was just built or commissioned OVM rebuild today, the bad guy is actually looking for this information. The reason why we saw nodes on the FireEye's devices is because there are specific routines within Ematet botnet that monitor for sandboxes and disassembly of the viruses. They check applications for history. User should have, again, not just being born yesterday or enabled yesterday, but should have some specific age to the system. Your browser should have history. Your applications should be a little bit used. You should have documents and everything else. And also look for consistent behavior patterns. With all that said, if your machine is really screaming sandbox, whether it's named victim PC or sandbox, whether it's trying to gather additional information, if it has specific disassembly software or any component of what I just mentioned, the bad guys would actually detect it. And they have specific routine within their malware to behave erratically. The cyber criminals actually laugh about our ability to detect certain behaviors simply because we don't always we always assume that everything behaves standardly. If they see that the machine is a sandbox, they start spewing out garbage and communication in collection patterns, confusing the researchers, adding additional components. And we saw one payload that was programmed to behave like another payload from a different botnet, specifically to throw the folks off and to figure out what's to really confuse their investigation efforts. So today we covered quite a few things, and hopefully it was useful to you guys to understand how botnets work, what kind of information is being gathered, what kind of abuses are possible, what botnets looking for, and how to detect and deal with them for attacks. This is all that I have to share with you today. And I'll be happy to answer any questions right now or later in Discord.